In example 2, it's a little more obvious that we're looking at a graph of the derivative. I know that because it says graph of f prime. So this is the graph of a derivative of the function f that I cannot see. A lot of the same analysis will work in this problem. This is an actual AP problem, 2007, Form B, number 4. Part A is talking about the open interval, -5 to 5, and it wants to know for what x values does f have a relative maximum, and then we have to justify our answer. Notice on this interval they are excluding endpoints, so no endpoint analysis is needed. And I'm going to say, pretty easy part here, f has a relative maximum at x equals, see, can you determine that? How about here and here? So at x equals -3 and also x equals 4, because we're going to say that f prime of x equals 0 at x equals -3 and 4, but also and f prime of x goes from positive to negative at these x values. Part B, on the same interval, find the x values at which the graph of f has a point of inflection. Justify your answer. I'm going to write the justification first, and the justification is going to be because f double prime of x changes sign at, and then I'll identify the x values where that happens. So that's what I'm looking for. I'm looking for where the derivative of the derivative changes sign. So of course, the regular derivative is positive here, f prime is positive, and f prime of x is negative because the graph is above or below. But I want to know, where does the second derivative change from positive to negative? The slopes along here are positive. That represents that f double prime of x is greater than 0 in the blue. Also, where else is f double prime positive? Well, it's going to go along here. F double prime is positive. F double prime is not defined here because of the corner, but then f double prime is positive here. The places where f double prime is negative occur here, perhaps a corner there, here, and here. Again, that's f double prime of x, the derivative of the derivative. And we have to see where f double prime changes sign. That occurs at x equals -4. That also occurs at -1. And that also occurs at 2. So f has a point of inflection at x equals -4, -1, 2, because f double prime changes sign at these x values. In part C, it wants to know where the graph of f, remember we can't see the graph of f, but it wants to know where the graph of f is concave up and simultaneously the graph of f has positive slope. So I've already outlined here in purple what it means to have positive slope. It means that the derivative graph is above the x-axis. So that would define f has positive slope. But in order f to be concave up, we know that the slope of the derivative has to be positive, and that is outlined in the different colors blue. So where do these simultaneously occur? F is concave up, and f has positive slope on the interval -5 to -4 in union with 1 to 2. The reasoning? Here we would say f double prime of x is greater than 0 on the interval -5 to -4 in union with -1 to 1 in union with 1 to 2. And then down here we would say f prime of x is greater than 0 on the interval -5 to -3 in union with 1 to 4. 1 to 4. Combining those to get our answer. Part D is going to require a little bit more work. They want to find the absolute minimum value of f over the closed interval -5 to 5. Explain your reasoning. The only way we can determine values of f is if they actually give us values. You can't tell from the derivative graph what the values of f are. So this little bit of information right here is going to be extremely valuable. F of 1 equals 3. There's no way of knowing that. They have to give us some condition. Going to use the closed interval test. So first, I need the interior critical x values. Interior critical x values. So I'm going to say that f prime of x equals 0 at x equals -3, 1, and 4 as observed by the graph. And now for my endpoint critical x values, I know we have at x equals -5, also x equals +5. Now I'm going to eliminate some candidates. I'm going to eliminate x equals -3 as a candidate because that represents a local maximum because the derivative went from positive to negative. Also, for the same reason, I'm going to eliminate the x equals 4. That leaves me with 3 candidates. I'll need to find the value of f at 1. I'll need to find the value of f at -5, and I'll need to find the value of f at +5 to determine which one is the absolute smallest. Luckily, f of 1 is given. It's given to be 3. We need that information to go further. Here's where it gets a little tricky. In order to find f at, let's do the 5 first. I need to incorporate f of 1 somehow. So what I'm looking at is the idea of the fundamental theorem of calculus that says the integral from a to b of f prime of x is going to be f of b minus f of a. Or, said differently, f of b equals starting f of a plus the integral from a to b of f prime of x dx. That's the fundamental theorem of calculus part 2. So I'm going to say f of 5 is going to equal f of 1 plus the integral from 1 to 5 of f prime of x dx. F of 1 is equal to 3. Now I'm going to appeal to geometry to find the integral from 1 to 5 of f prime. That'll have me look at this triangle in red, and then this triangle in blue. So let's come down here. The area of the red triangle is going to be 1/2. The base will be 3, and the height will be 2. And then I need to subtract the blue triangle, which is 1/2, a base of 1, and a height of 1. Which will give me 3 plus 6/2 minus 1/2, or plus 5/2. 3 plus 5/2. Now for f of -5. F of -5 will be f of 1 plus the integral from 1 to -5 f prime of x dx. so that will be 3. But I'm going to subtract so that I can flip the integral, -5 to 1 f prime of x dx, which will give me 3 minus, I'll appeal to geometry to get the integral from -5 to 1. That'll have me look at the circle in green, and then I'll have to take away the area of the circle here in pink. The green semicircle will have an area of pi over 2, and then I take away the area of the pink, which has an area of 4 pi over 2, which will give me 3 minus a minus, so plus 3 pi over 2. Aha! This value here is 3, this is 3 plus, and this one here is 3 plus, so my absolute minimum is 3 by the closed interval test. I do not have to say by the closed interval test as long as I execute the closed interval